This video is going to cover Module 2 Homework 3 notes. We're getting into the introduction of functions. So in doing so, we have to have some definitions first. It says a relation is just a set of ordered pairs, a group of ordered pairs. A set in mathematics is a collection of objects, and then we show that it's a set by showing our curly brackets. So for example, we have our curly brackets, which denotes this is our set, this is our group, and our ordered pairs is 1, 2, -1, 3, and 2, 2. So we can map this set of ordered pairs and create a mapping diagram. So these ordered pairs are x, y. So my x values are going to map to my y values. So my x value is 1, and it's going to map to 2. So when 1 goes in, 2 goes out. When -1 goes in, 3 goes out. When 2 goes in, 2 comes out. Notice 2 is already up here, so I don't need to write it twice. I'm just going to point an arrow up here that whenever 2 goes in for x, 2 comes out as y. So that is our mapping diagram. It maps our x values to our y values. So the domain is a relation is the set of x values, the inputs, and remember that's going to be our first component of our x, y ordered pair. So -1, 1, and 2 are going to be our domain. This first column is going to be our domain for this relation. The range of the relation is the set of y values, the output, and it's the second component of our ordered pairs. So in this case, 2 and 3 are our range. So our domain for this example is the set. So we're going to have our curly brackets of -1, 1, and 2, our x values. And then our range is our y values. So again, it's our set. So we have our curly brackets of 2 and 3. So big thing, domain is what you put into the function, and then your range is the values that you get out. Next page. Now talking about relations, we have to say, okay, now that we know that it's a relation, is this relation a function? So a function is a relation in which every element in the domain, so every element in the domain, so that's every x value, corresponds to exactly one element in the range. Remember, the element in the range is our y values. So that's the biggest thing, exactly one. It can't be more than 1, it can't be less than 1. So every x has exactly one y value. So going back to our mapping diagrams, we need to know that every x has an arrow. Every x has an output going out of it. And then there's only one arrow out of every x. So notice, we don't talk about y at all. So it doesn't even matter what if our y values are repeated as long as the x values are not repeated. So we do not consider our y values. We're only looking to see, does every x have exactly one arrow going out of it? Does every x have exactly one y value? So looking at these mapping diagrams, is the relation a function? So A goes to 2, B does not have an arrow, so that is going to be our problem. So every x does not have exactly one y, so that is not a function. Looking at our next example, A has one arrow, B has one arrow, C has one arrow. Every x value, remember these are x, y, so x is first and then y. Every x value has exactly one arrow, so yes, that is a function. Lastly, for our x and our y values, A maps to 2, B maps to 1, C maps to 2 and to 3. This is not a function because C has more than one arrow. So every x does not have exactly one y, so no, that is not a function. So now it asks us to draw a mapping diagram for the relation 1, 2, 1, 4, and 2, 8. So we have our x values and we have our y values. Making our little circles there. So I know for my first ordered pair is 1, 2. So 1 maps to 2. Whenever 1 goes in, 2 comes out. The next one is 1, 4. Whenever 1 goes in, 4 goes out. Again, 1 is already there, so I don't need to write another 1. We're just going to draw an arrow from that 1 to 4. And lastly, whenever 2 goes in, 8 goes out. So I need to draw an arrow from 2 to 8. So it asks us, is this a function? No, this is not a function because our 1 has more than one y value. If the x value is repeated, like in this case, 1 is repeated, then the relation is not a function. Next, it asks us, our domain is. So domain is our x values. So that's going to be 1 and 2. Our range is our y values in this column here. So we have 2, 4, and 8. So notice it says use commas to separate your answer. Next page. Again, consider the relation 1, 4, 2, 4, and 3, 5. Is this relation a function? And then find the domain and range. So same concept. We need to have our mapping diagram. So our x and our y column. The first order pair is 1, 4. So 1, 4. 1 maps to 4. The next one is 2, 4. So I need to draw an arrow from 2 to 4. Again, 4 is already written there, so I do not need to write it twice. And then lastly, we have 3, 5. So I need to draw an arrow from 3 to 5. Is this relation a function? Yes, every x value has exactly one arrow going out of it. So yes, this is a function. And then lastly, find the domain and range. So our domain is a set of numbers, so we need to show that using our squiggly brackets. Domain is our x value, so this first column, so 1, 2, and 3. We're going to separate those numbers using a comma. Our range is our second column, which is our y values. So in this case, it's going to be 4 and 5. Again, it's a set of numbers. It's a group of numbers, so we need to draw our nice squiggly brackets to show that. So just to reiterate, the most important fact from these examples, if the x values are repeated, then the relation is not a function. Not a function. All right, so using function notation now. So notation, just like set notation and interval notation, is our way of writing and naming a function. So we've talked about domain, our inputs, our x values. So in goes our x values, our input, through the function, and then out comes our output, which is our y value. We're going to label our function f of x. It could also be g of x, h of x. That's just the name of the function. So function notation, since the y value is determined by what is put into the function by the input, we say that y is a function of x, because whatever you put in determines what you get out, and we write it as y equals f of x. So y equals f of x, so f in parentheses x. We read it as f of x. And this notation indicates that the variable x is being put into the function f. Notice that the parentheses here do not show multiplication. They just show us what is being put into the function. Into the function. Okay, so it says write the example using function notation. We're going to write it using f of x. So I know that our y is the same thing as writing f of x. So I want to solve this equation for y. I'm going to solve this equation for y. I'm going to get y by itself. So we have 4x minus 8y equals 8. I want to try to get y by itself, so I'm going to move this 4x to the other side. It's a positive 4x, so I'm going to do the opposite, and I'm going to subtract 4x from both sides. So that way 4x minus 4x goes to 0. They cancel out. We're left with negative 8y equals negative 4x plus 8. And then lastly, getting y by itself, this negative 8 is multiplying to our y. So we're going to do the opposite, and we're going to divide both sides by negative 8. That way, negative 8 divided by negative 8 goes to 1y, and those cancel each other out. Notice I'm dividing the left whole side by negative 8, so that means the right whole side. Both terms get divided by negative 8. So we are left over with y equals negative 4 divided by negative 8x plus 8 divided by negative 8, which we can simplify as y equals negative 4 divided by negative 8. We'll simplify to positive 1/2. They both have a negative 4 that we can divide out at the top and the bottom. Negative 4 divided by negative 4 is positive 1. Negative 8 divided by negative 4 is positive 2. So positive 1/2 x, and then 8 divided by negative 8 will leave us with minus 1. So now we have it into y equals. The only last thing we know here is that y is the same thing. Y equals f of x. So instead of y, we can use function notation. We can use f of x and say f of x equals 1/2 x minus 1. This way we know that x is being put into our function. And that will be our final answer for that one. All right, so now evaluating a function. The whole point of function notation is to see the input, to see what you're putting into the function. So it asks us to evaluate f of x equals 6x plus 1 at each given value of the independent variable. Our independent variable is going to be x, whatever you're independently putting into the function. And then we're going to simplify. So if we have f of 12, it's telling us to put 12 into our function. Notice instead of x, they wrote 12. So what they did, so left-hand side, we are also going to do to this right-hand side. So 6, we're going to put 12 into our function for x plus 1. 6 times 12 will give us 72 plus 1, which will give us 73 as our final answer. Same thing for the next example, example B. It says f of x equals x plus 9. So they are putting x plus 9 into the function for x. So 6, we're going to put into the function, instead of x, we're going to put in x plus 9 plus 1. So 6 times x plus 9 plus 1. And now we're just going to simplify. So let's start by distributing. So 6 times x would give us 6x. 6 times 9 would give us plus 54 plus 1. And then last but not least, combining like terms, 54 plus 1 will leave us with our final answer of 6x plus 55. Final answer. Same thing for the next example. It asks us to evaluate the function f of x equals 3 at the given values of the independent variable at the given x values and simplify. For example A, they ask us to find f of 1/2. So they're plugging in 1/2 in for x. So our function, or f of x, is just 3. There's nothing to plug in. There's no x over here. So no matter what x is, it's still going to equal 3. So f of 5, there's no x value to plug in. It's still going to be 3, either way. All right, so we used a mapping diagram earlier to see that, okay, is a relation a function or not, as long as every x value has exactly one y value. So now we're going to do the same concept, but we're going to do it graphically. We're going to see, is the relation a function or not? So to do so, we're going to use the vertical line test to determine whether the graph is a graph of a function or not. So looking at this first graph right here, it asks us, does every vertical line intersects the graph only once? Yes, no matter what vertical line I draw, it's only going to intersect, it's only going to hit through this graph one time. So yes, this is a function. Every x value only has exactly one y value. Over here, if I draw a vertical line, let's say for example right here, it fails the vertical line test. This x value has two y values, so no, this is not a function. It fails the vertical line test. We found a vertical line that intersects the graph twice or more. So if a vertical line intersects the graph twice or more, then it is not a function. All right, next page. Finding domain and range. We already did this earlier using a mapping diagram, but now we're going to do it graphically. it asks us to find the domain and range in interval notation, and then we're gonna see is the relation a function. Remember that we're gonna use parentheses for open circles and infinity because those numbers are not included, and otherwise we're gonna use square brackets to show that those numbers are included. So remember, our domain is our x values. So on our graph, our x-axis is the horizontal one that goes from left to right, because it's going to go from smallest to largest. So we're going to look to see where does our graph start on the left-hand side, and then where does it end on the right-hand side. So looking at this, the furthest left point we have is right here, which has a y value of -2. So our domain is starting at -2. That's the furthest left smallest x value. If you notice, at -2, there is an open circle. So that means -2 is not included. And we are going to show that in interval notation by using a parenthesis. All right, so the graph is going, all's good and good. And then the furthest right point is this point right here, which is at +1. So that's going to be our largest x value. So our graph's going to go from -2 to +1. At that +1, that is a closed circle, so 1 is included. So we're going to show that using a bracket. So again, our domain goes from left to right. All my x values are between -2 and 1. Not including -2 because it's an open circle, but it's including 1 because that is a closed circle. Same concept for our range. This time though, our range is our y values. So our y-axis is vertical, so now it's going up and down. We still want it from smallest to largest. So our smallest numbers are at the bottom, so we're going to go from the bottom, the lowest point on our graph, to top, the highest point on our graph, the largest number on our graph. So the lowest point on my graph is down here at -1. At -1, that is a closed circle, so it's included, so we're going to use a bracket. And the highest point is going to go right here. That's our highest point at +2. That +2, because we're just looking at our y values on our y-axis, that +2, there's an open circle there, so +2 is not included, so we're going to use a parenthesis to show that. So these are our values for our range, which go from bottom to top. We're just looking at our y-axis. Our y values go from -1 to +2, everything in between there. So that's it for our domain and range. Lastly, it asks us, is this relation a function? So every vertical line that I draw going up and down only passes through this graph one time. So yes, this is a function. Yes, this is a function. All right, for example B, same concept for our domain and range. Starting off with our domain, we're going from this furthest left, let me start over. We are starting from the furthest left x value, and then we're going to the furthest right, from the smallest to the largest x values. So I see this is the furthest left smallest value for my x's, which is at -1. There is a solid point there. All of these lines is just an infinite number of closed circles. Put together makes it look like a line. If it's gonna be an open circle, it is literally like this first one gonna be an open circle. So -1, there's a closed circle there, so -1 is an x value. It is included, so we're gonna use a bracket. And then looking on the right-hand side, I'm looking, it's going over, and then these arrows tell me that it's going on forever to the right-hand side. So if it's going on forever to the right-hand side, it's going towards positive infinity. Remember, positive infinity, we can never include that because we can never reach positive infinity. So we're going to use a parenthesis to close off that interval notation. All right, so that's our domain. Same concept for our range. This time we're going from the bottom of our graph, the lowest point, to the top of our graph to the highest point. So if you notice, this graph is going to go down slowly forever. So if it's going down forever, it's going towards negative infinity. Like we talked about, for infinity, we can never reach it. So it is going to be a parenthesis. Then our graph is going around, and then if you notice, it's going up slowly forever. So because it's going up forever, it's going towards positive infinity. We can never reach infinity, so we're going to use a parenthesis. So that's our domain and range. Now we need to see, is the relation a function or not? So if I draw a vertical line anywhere, let's say I draw a vertical line right there, that dotted vertical line, it passes through my graph more than once. So that x value of positive 5 has more than one y value. So that means no, this is not a function. No, this is not a function. All right, so example C. Example C. Again, domain and range. This time we have a circle, but it's going to be the same concept. Starting with our domain, we're looking at our graph from left to right. This looks like it's the furthest left x value, which is -4. These are all closed circles, so -4 is included. -4 is an x value, so we're going to use a bracket. The graph is going. This looks like it's my furthest right point, which is at +2. Again, there's a closed circle there. +2 is an x value, it's included, so we're going to use a bracket to show that. And that's from left to right, from smallest to largest. And then our range, same concept. This time, instead of going from left to right, we are looking just at our y value, so from the bottom to the top of our graph. This looks like it's the lowest point on our graph, which is at -5. There is a closed circle there. I know that that point is included. -5 is a y value, so we're going to use a bracket to show that. This looks like it's the highest y value, the highest point on our graph, which is at +1. Again, +1 is a y value. It is included. There's a closed circle there, so we're going to show that with a square bracket. So that is our domain and range. Lastly, is this a function or not? No, it is not. Any vertical line that I draw, let's say you draw a vertical line through there, it's going to hit this vertical line. The graph is going to go and intersect this vertical line more than once. So no, this is not a function. No, this is not a function. All right. And that is all of Module 2, Homework 3 notes.